Hello and welcome back to Nursing with Evangel. So today we're going to dive into what your body does 24 hours a day without you knowing. And that is what we call urine formation. In our last video, we talked about the anatomy of the kidney, and there we listed out the functions of the kidney and also mentioned that it plays a role in formation of urine. So let's dive in and see how the kidney produces urine. So the urinary system is like the body's plumbing system, and its function is to remove wastes from the body. The waste, and that waste is called urine. So inside the urine, there are so many wastes that your body does not need. We have the urea, the nitrogenous waste, creatinine, and so on. So it is through the urine that the body takes off all this excess or toxic waste from the body. In our last video, where we talk about the anatomy of the kidney, we established the fact that each kidney has about 1 million nephrons. So these nephrons are responsible for producing the urine that we're going to talk about in this video. In fact, the kidney filters about 180 liters of blood per day, but only about 1 to 2 liters comes out as urine. That depends on the hydration status of the person. So let's see what happens to the rest. That is going to lead us to our actual topic for today, which is urine formation. So before we go into that, let's look at the nephron and see what it is. The nephron is made up of a renal corpuscle, which includes the glomerulus and Bowman's capsule. It also has the renal tubules, which are the proximal convoluted tubules, the loop of Henle, and the distal convoluted tubules. And this nephron also has a collecting duct. So now the process of urine formation involves 3 major steps, which are filtration, reabsorption, and secretion. So my lecturer put these steps into an acronym, and she calls it Father Remember Son. So once you remember this acronym, it's going to help you to remember the stages of the formation of urine. So let's look at what these stages are and where they take place. The filtration, which is the first stage, takes place basically in the glomerulus, while the second stage, which is the reabsorption, takes place in the proximal tubule. The secretion is in the distal tubule, and the collecting duct is of the nephron. So after all this happens, the end product is the urine, which flows from the ureter into the bladder. So now let's see how this glomerular filtration works. It happens in the renal corpuscle, specifically the glomerulus. And this glomerulus is a cluster of arteries, is a cluster of capillaries under high pressure. So it is the pressure in the glomerulus that leads to this filtration we are going to talk about. So the blood enters through the afferent arteriole, and then it goes out through the efferent arteriole. So think about the afferent, where it enters from, and the efferent, where it leaves. So the pressure in the glomerulus, that is what causes the filtration of the blood, which later comes out as urine. In the process of the formation of urine, water, glucose, electrolytes, urea, and small amino acids get filtered, and then the blood and plasma proteins do not get filtered. This is because they are too large to pass through the semi-permeable membranes of the glomerulus. So in a condition whereby the blood cells are present in the urine, that is an indicator that there is a problem with the kidneys. So during this filtration, not everything gets filtered. After filtration, the body has to reabsorb the materials that are needed, materials like water, electrolytes, etc., etc. So this is because not all of them get filtered at the same time. So when the blood leaves through the efferent arteriole, it also has a way of coming back into the urine, and then the waste product also have a way of being secreted into the urine. So that's going to take us to the second stage of urine formation, which is the selective reabsorption. So this selective reabsorption happens because your body does not want to lose essential materials like glucose, amino acids, water, and electrolytes. So it's using this mechanism to draw them back to itself. This selective reabsorption takes place in the renal tubules, which are the proximal convoluted tubule, the loop of Henle, and the distal convoluted tubule. So in the proximal convoluted tubule, about 60% of the filtered water and sodium is reabsorbed, and 100% of the glucose and amino acids is also reabsorbed. And then at the loop of Henle, more water and salts are reabsorbed to make the urine concentrated, because your body doesn't want to lose all the water and the sodium that it already has, because these are needed for physiological activities of the body. On to the distal convoluted tubule and collecting ducts, they reabsorb water based on the body's needs, thanks to the antidiuretic hormone and aldosterone. So this antidiuretic hormone, it helps you to reabsorb water when you are dehydrated. And then the aldosterone promotes sodium reabsorption. And remember that when there is sodium in the body, it's going to help you to retain water so you don't get dehydrated. So this step is all about saving what you need and avoiding dehydration or nutrient loss. Now let's talk about the last step, which is the tubular secretion. And it is your kidney's chance to throw away all those substances that are not needed. So these substances are still in the filtrate, but they are no longer needed by the body. So it just tells them it's time to go. So what are these substances that are secreted? We have the hydrogen ions. These hydrogen ions are secreted to maintain pH balance. Also the potassium ions to prevent hyperkalemia, which is a condition whereby the potassium levels in the blood is high. And also ammonia and creatinine are waste products that the kidney excretes through urine, and also some certain drugs. This secretion helps to regulate acid-base balance and remove harmful substances from the body, so that the body is going to be free from these substances. So any blood going back into circulation is free from all these substances. That is why we have to appreciate the kidneys and keep them safe at all times. Let's see how this urine leaves the body. Remember the collecting ducts we talked about when we described the nephron? This collecting duct now collects all the urine and pushes it to the renal pelvis. So it is from that renal pelvis that all the urine is now channeled through the ureter down to the bladder, and then from the bladder it is channeled out of the body through the urethra. Don't get confused. We have the ureter and urethra. Ureter and urethra. So the ureter carries the urine from the renal pelvis to the bladder, and then the urethra carries the urine down to the outside of the body. Let's see why monitoring urine output is important in nursing care. This is because it gives a baseline of kidney health. So common indicators of kidney health include the glomerular filtration rate, which is the rate at which the glomerulus filters the blood, and also have the blood urea nitrogen, the creatinine levels, urine output, and composition. And that wraps up our dive into the urine formation. So we've just learned a concept that affects fluid balance, blood pressure, pH regulation, and so much more. So if this video helped you, don't forget to like, subscribe, and hit that notification bell so you never miss any tutorial from Nursing with Evangel. If this video helped you, don't forget to like, subscribe, and hit that notification bell so you never miss a tutorial from us. You have to subscribe so that you'll be among the first people to get the notification when a new video comes up. Until next time, keep learning and keep caring. Bye.